This is about the evolution of testing, going from spec-driven development to property-based testing, or PBT. Here's what we're solving. How do you create a direct, verifiable link between requirements you specify and what your code actually does? We're going to use a traffic light controller as our example throughout this video. And here's the safety requirement for traffic lights. Two directions must never be green at the same time. Sounds simple, right? Cars going north and cars going east should never both have a green light. That would be bad. But testing this correctly? Way trickier than you'd think. Let me show you exactly how this works in 4 steps. Step 1. Natural language requirements. You start with plain English. Your acceptance criteria. Two directions must never be green at the same time. Clear, human readable, but you can't run it as code. Step 2. Textual properties. Now transform it into a universal statement. For any sequence of operations at every point in time, at most one direction has a green signal. See that phrase, for any? That's the key. Properties describe behavior across all possible inputs, not just examples, everything. Step 3. Executable property tests. Now it becomes real code. This uses hypothesis, a property-based testing framework. That given decorator generates hundreds or even thousands of random operation sequences. And for every single one we check, is there more than one green light? Step 4. Minimal counterexamples through shrinking. This is where the magic happens. When a test fails, it doesn't just say, failed. The framework found a failure with 47 random operations. But then it shrinks that down to the minimal case. 2 operations. That's it. That's all you need to break the safety rule. By shrinking down the operations that result in breaking the safety rule, the bug is now obvious. Now, let me show you how property-based tests work in practice, using spec mode in Kiro. Kiro's spec mode writes requirements using the ears notation, or easy approach to requirement syntax. Look at this traffic light requirement. When a signal transitions to green, the system shall ensure no other direction has a green signal. Ears notation provides structured, constrained natural language templates that reduce the ambiguity inherent in traditional requirements writing. This structured format enables formal reasoning, and Kiro does this in 3 steps. First, Kiro writes requirements in ears format. Then it extracts testable properties from those requirements. Finally, it generates and runs hundreds or even thousands of test cases automatically using property-based testing libraries, such as Hypothesis for Python. Here's what a property actually looks like in Kiro's design document. See how the property is structured here? For any sequence of operations, state transitions, emergency modes, timing updates, at every point in time, at most one direction should have a green signal. 3 things to notice here. First, that for any tells you it's a property, not just an example. Second, it links directly to requirement 2.3, full traceability from tests back to requirements. Third, it connects to actual executable test code, requirements to properties, to tests, to code. Every link is explicit. Now here's where property-based testing really shines against traditional unit tests. Each cell you see here represents a unique combination of operations. Watch as property-based testing randomly samples across the entire input space. Because the human doesn't have to explicitly write every test, there's no bias and no blind spots. A human might write 5, maybe 10 test cases, limited by imagination and time. Property-based testing can generate over 1,000 tests, exploring edge cases you'd never think to check. That red cell? That's a failure found through property-based testing, a bug that traditional testing might have missed. When property-based testing finds a violation, It doesn't just fail. It shrinks the failure down to a minimal counterexample. Kiro then gives you 3 paths forward to fix the failure. Fix the spec. Maybe the requirement was incomplete. Fix the implementation. Maybe the code doesn't match intent. Kiro can even auto-fix this. Or fix the test. Perhaps the property was overspecified. Kiro gives you control by allowing for human judgment combined with automated testing.